So today we're going to take a look at graphing some more of these rational functions. So yesterday we used Desmos quite a bit. So let's see, what can we identify in these functions? Yesterday we talked about asymptotes. And so it looks like there's an asymptote on this one, right here. So there's that x equals 3. And if you remember from yesterday, that makes sense because in the denominator, 3 minus 3 is 0. And right here, it looks like there's another one at y equals 0. And let's see, well, that makes sense because as x gets really, really big or small, we'd have 2 over a really big number, which is close to 0. Otherwise, we can think the biggest degree is on the bottom, so it's at 0. Let's see, we also talked about x-intercept, so there isn't one. Well, here is our y-intercept. So if we plug in 0, 2 over 0 minus 3, so that coordinate is 0 and negative 2/3. So that one's a pretty basic one. We looked at that yesterday. But let's take a look at this next one here. Well, once again, there's asymptotes, and we talked about yesterday how you factor. So this one can factor into x plus 2x minus 1 divided by, let's see, so this would be x minus 3, x minus 1. So let's see those asymptotes here. Well, there's this one at x equals 3. Well, that makes sense. We have a 3 in a denominator. Right here, y equals 1. And so we can think again as x gets really, really big, those don't matter. So it's really x squared over x squared, which is 1. Or we talked about yesterday how they're both the same power, so we'll just divide them. Let's see, we got an x-intercept right here. So that's negative 3 and 0. Y-intercept, well, what happens if we plug in 0? Those are gone, so negative 2/3. But what's going on here? Like, we have a whole. So what in our equation might tell us the whole? Well, it's this part right here. If terms cancel, we end up with a whole. So there's a whole at x equals 1. Now let's look at this one and see what we can find. Okay, so there's an asymptote right here. Negative 2, well, that makes sense in our equation. In the denominator, negative 2. There's 1 at y equals 1. And does that make sense? Well, yes, as x gets really big, those don't really matter. Minus 3 and plus 2, so x over x is 1. There aren't any holes. What else do we have? We have a y-intercept there. So if we plug in 0, 0 minus 3 over 0 minus plus 2. So we have 0 and negative 3 over 2. 1, 2. So that's 3. So 3, 0. Well, that makes sense. When we plug in 3, 3 minus 3 over 3 plus 2 is 0 over 5, which is 0. Let's look at this last one. This is strange. Well, there appears to be a vertical. It says count by 5s on the x-axis. So right there's a vertical. Well, it makes sense from our graph. That's x equals negative 2. Y-intercept, so that's 5, 0. And it looks like there's another one there. Well, let's see. Let's try factoring this. What does this factor into? So multiplies to negative 10 and adds to negative 9. So 2x squared, so let's see, that'd be negative 10x plus 1x minus 5. Oops, that's positive 2. So factor out of positive 2x, so x minus 5. Factor out of 1. So the numerator is 2x plus 1 and x minus 5 over x plus 2. Well, nothing cancels, so there's a whole. But there's this weird asymptote here. It looks like it goes something like that. And this one we haven't talked about. We haven't talked about a slant asymptote yet. And if you look at our equation, as x gets really, really big, this big number's on top and divided by something. So our slant is when that big number's on the top. So what we're going to go through now is a checklist for finding these. So when you have a graph, the first thing you want to find is the y-intercept. And how do we do that? We plug in 0 for x. The next thing, find the horizontal asymptote, and we should put here horizontal /slant asymptote. Because for both of these, we think as x gets big. And then we can also, to help us out, we look at the degrees of the numerator and denominator. So if the numerator is less than the denominator, that means the big number's on top, so it's just at y equals 0, because you'd have a small number over a big. If it's equal to each other, everything but the big degrees cancel out, so it's y equals, and that's where we divide. And if the numerator is greater than the denominator, that's when we have a slant, and we have to use long division. So we're going to take a look at a couple of these here. So on this sheet, we're going to decide whether it's a horizontal or a slant. So this first one is x gets really big. Well, this stuff wouldn't matter, so it's just x squared over x squared. So that's just y equals 1. And we can see that the degree here is the same. The next one, as x gets really big, this stuff again wouldn't matter because we have that x squared, so 6x squared over 2x squared is 3. And if you notice, they're both degree 2, so that we can just divide. This next one here, as x gets big, x squared is going to be a huge number. X is still big, but it's a big over a huge, which is equal to y equals 0. So if you look at your degree, the small one's on top. If you look at E1, once again, the biggest number is on the bottom, x squared, small one on top, so that's again y equals 0, because that degree there. This next one, let's see, well, the big number's on the bottom, -3 is not going to matter, so it's going to go again to y equals 0, because -3 over a huge number is really close to 0. And now this E5, if you'll notice, there is the biggest number's on the top. So we're going to have x squared on the top. It's just going to keep getting bigger and bigger. So we have to divide and use long division. So x minus 4 goes on the outside. X squared on the inside. So that means this is x. X times -4 is -4x. We want just 1x. So that has to be 5x. Because now that's our 1x right there. Plus 5, so 5 times -4 is -20. And let's see, the number we want is -12, so that would be a remainder of 8. So our slant, we don't worry about the remainder. It's just x plus 5. So here's another one, that big number's on top. So we do that long division. And I'll leave you to do that long division there and see what you come up with. So this one is going to be a slant. So your final answer is going to be y equals some equation. E4, when you think about that one, the big number's on the bottom, so it's y equals 0. Let's see, 3x and 2x, so they're both pretty big. There's no powers, so 3x over 2x is just 3 over 2. Let's see, the big number's on top, so this would be another slant, and we divide, so it's y equals something. Let's see, we got 3x and x squared, so the big is on the bottom, so that's going to be at y equals 0. And this one, let's see, well, this is going to be 0, 1 over a big number, so it's just y equals x, as x gets really big. So that's kind of a little review there of how you find the horizontal asymptotes. So once you find that, you factor and simplify. You find the wholes, and this is the term that reduces out. And so it's the 0 in the term. Verticals are zeros in the denominator. And then the x-intercept, that's you just plug in x for y. You plug in 0 for y, excuse me, and solve. So we're going to take a look at a couple of these here and see if we can identify this stuff. So the first one we're going to take a look at is f of x equals x squared plus x minus 6 divided by 2x squared plus 5x minus 3. So our first step, find the y-intercept. So if we plug in 0 for x, if we plug in 0, 0 squared plus 0 minus 6, 2 times 0 squared plus 5 times 0 minus 3, so negative 6 over negative 3, which is 2. So it's the coordinate 0, 2. Horizontal or slant. So if we look at the degrees, they're the same. So we divide those. So it would be at 1, y equals 1 over 2. Factor and simplify. Well, I already factored this one for you. So I'm going to tell you that it factors into x plus 3 times x minus 2 over 2x minus 1 and x plus 3. So it simplifies to x minus 2 over 2x minus 1. So that means that there's a hole at x equals negative 3, because that term reduces out. Where's our vertical? When the denominator is 0. So when does 2x minus 1 equal 0? Well, we add 1 and then divide by 2. So it would be at half. And then our x-intercepts. Plug in 0 for y. So 0 equals x minus 2 over 2x minus 1. If we fraction bust that, multiply by the denominator, so we have 0 equals x minus 2. So it's at x equals 2, so it'd be at 2 and 0. The next one we're going to take a look at. Y equals 2 over x plus 1 minus 2. So let's find our y-intercept first. If we plug in 0, 2 over 0 plus 1 minus 2, so 2 minus 2, so that's 0. So it's at 0, 0. Our horizontal, so let's see. Well, the biggest degree is at the bottom, so this would be y equals 0, but we have that minus 2. Well, that makes sense. This is like that shift. So it's at y equals negative 2, because it's moved down 2. Let's see. We can't factor, so our vertical, there isn't a hole, would be at x equals negative 1. And then our x-intercept. So we plug in 0 for y. 2 over x plus 1 minus 2. Add 2. So we have 2 equals 2 over x plus 1. Fraction bust. We have 2 times x plus 1 equals 2. So 2x plus 2 equals 2. So 2x equals 0. So it's at x equals 0. So we have 0, 0, which we knew from before. So the very last one we're going to look at. Let's look at x squared plus 3x minus 10 over x minus 3. So our y-intercept, when we plug in 0, we're just going to 0, 0, 0. So we have 10 thirds. So it's at 0, 10 thirds. Horizontal or slant. So I look at it, let's see, the bigger number's on top. So that means that there's a slant and we have to divide. So we have x minus 3. X squared there, so x times x, that would make negative 3x. We need positive 3x, so 6x. So plus 6, 6 times negative 3 is negative 18. We only want negative 10, so we have an 8 there. So it's at y equals x plus 6. Our vertical, what's in the denominator, would be x equals 3. And then our x-intercepts. Oops, I forgot to factor this. And this factors into x minus 2 times x plus 5 over x minus 3. So when does 0 equal all of this? So we fraction bust. So we have 0 equals x minus 2, x plus 5. So it would be at